Hello everyone. So let's wait for a few minutes, then we'll start. Till that, I will share my screen. So what we are going to cover today? So we are going to cover the basic introduction of the fine-tuning methods like SFT instruction fine-tuning, Pete LoRa, prompt tuning, Q LoRa, long LoRa for domain specific, dataset generation using LLM model for fine-tuning models, introduction to model quantization, understanding the agents, and exploring the agentic agent. Okay, and function calling to execute the dynamic task. Okay, to execute the task dynamically. Okay, this is what that we are going to cover. Okay, so everything is available on our website hidevs.xyz. Okay, so xyz. Okay, so everything is here, you can see all the programs. Okay, so once you will click on learn more, so you will see the curriculum cohort is going on. This is academy link. So once you will click on the academy links, this is our program. So currently we are exploring this one. It's loading, so wait for 1 or 2 minutes. Yeah, introduction to fine tuning and quantization. Okay, so we'll start in next 1 or 2 minutes. Let's wait. Okay, so we'll start. Okay, so basically, let me share my other screen so I will able to explain you. Yeah, so what is the need of the fine tuning first of all? So as we know, so currently LLM models are available. So only two ways available in the market to use that particular LLM model, either prompt engineering, okay, or fine tuning. But after doing the fine tuning as well, we have to use the prompts engineering. Okay, but why there is a need of the fine tuning and when we have to be apply the fine tuning? Okay, that's the one of the most important question that you should always be cautious. You should always be asked from yourself. So take an example that some project has been given to you. Okay, some project has been given to you by the any your company, anyone. So first you have to be figured out after doing the like good prompt engineering, is it the accuracy is not good? Okay, it's not good, and you are seeing there's a no improvements. Okay, no improvements is going to be happen after doing a lot of changes. Okay, after doing the lot of changes in the prompt engineering, then you have to decide and go in the fine tuning path, because fine tuning part is very expensive. How it's expensive, we will look into it. Okay, so first of all, if we will compare the prompt engineering. Okay, so prompt engineering, or we can say the RAG project. Okay, so this is a requirement of the first project. So what is required in this is token. Okay, or LLM model, we can say, or LLM model API. Okay, you are using first this one. Okay, second, you will host your application. okay, on any cloud service. Okay, this is second. And after that, data related task. Okay, related task is there, which involve any employee time, okay, and efforts. We can consider something like this. So in that condition, only these three things are available, only these three things, okay. But in the case of the fine tuning, this is not a case. The first step that you have to do, which is data collection, okay, or generation. Okay, this is most important thing. Okay, nowadays there are a lot of the tools are available which is giving you the generate the data, but I will not recommend you to work on that particular data. Why I will not recommend you? To be honest, when you are generating the data, when you are generating the data on the base of the any other tool, so what will happen? They will give you the synthetic data. This is not like actual data. Now if you will see on my screen how fast I am typing, how many mistakes that I am doing, so in that case what will happen? Data quality is not good. Okay, so in that case what will happen? You will make the changes in your data. So you need actual data of the human generated data, not machine generated. So in the case of synthetic data that you are going to be used by the any LLM model generated, and then you will fine tune it, I will not recommend it. Personally, I will not recommend it. It will not going to give you the good accuracy. Rather than that, whatever your specific task, fine tuning for the specific task always, okay, whatever your specific task or the problem that you are solving, so I will recommend you go for that particular specific task, and then collect the particular collect the data according to your specific task or the project, which is totally or most of like 75% should be human generated, not the machine generated. Otherwise what will happen? There is a scenario that you have created a model on the basis of the particular machine, okay, machine generated data, and other side you creating the model on the human generated or human created data set. Both accuracy will be different and both will work differently on the production side. So I will not recommend. Okay, this is one. So here the time will go. After that you will fine tune it. Okay, so fine tuning is going to happen on GPU only. You need a proper GPU. Okay, after that doing the training you have to be reiterate until unless you will not get to the proper accuracy that you are looking for. Okay, so you have to reiterate the multiple times. It's not going to be happen into the single time. No, it's not going to be happen. Okay, so you have to be reiterate every time. How it will be reiterate? Like the prompt, the same way that we are doing the prompt, the same way that we have to do here as well. Okay, I think am I audible to everyone? I doubt like I'm not audible. Let me check. Hello, hello. Let me check. It's audible? Yeah, it's hello, audible. Hello. Yes, please check. Yes, sir, you are okay. Thank you so much, Dilip. Thank you so much. Okay, so in that case you have to be generate the data. Okay, you generate it and you have to be fine tune it. Most of the time you have to fine tune on the iterative manner, so that way again take the GPU only. Once you will do it, then you create your own model, then you have to host your model. Okay, in the case of here you using the API, okay, of the LLM model. API by like either by Grok, okay, or AWS or ChatGPT, sorry, OpenAI, whatever it is, okay, or GCP, whatever the service. So you are using directly API. You don't deploy your own model, but in this case you have to deploy your own open source model, which is going to take again the pricing. Okay, then you have to convert this as a API as a service. Okay, and after that what will happen? All these things you have to be copy paste here, something like this. So see, the efforts in the case of the human is high. The efforts in the case of the like time is also high, and also the pricing is also high. So there is a no company who will give you the particular set of the thing and say ki go and directly fine tune it. No, they will try first with the prompt plus rec, then you will try it out, see how well that it's working, then they will decide do we go in that direction or not. So this is what that you have to be keeping in your mind as well. So I'm saying always that you have to be become a programmer, not a coder. Okay, so you have to be make yourself properly. Okay, make yourself properly understandable. What is the benefits? What are the advantage versus disadvantage to doing the fine tuning and doing the prompt plus rag? Okay, all these things. Once because you are once you will fine tune a particular model, fine tune a model on a specific task, okay, then you are only replacing the first point. Okay, you are only replacing the first point. After that you have to do all the things again prompt you have to do, rag you have to do. Okay, all the things that you have to be consider into your particular project, like project life cycle. Okay, so this is all about the prompt versus fine tuning. Now what are the different ways are available to do all these things? So again there are a lot of ways. I always say there are a lot of ways are available to do all these kind of the things. So you have to be go again different types of the fine tuning methods. So we will see what are the different fine tuning types of the methods. Okay, so I will share my screen of that as well. So we'll see fine tuning ways in LLM model. See, so there are a lot of ways. I think yeah, I think it is available here only. Na, why I am open. See, feet. Okay, Pete, fine tuning methods, LoRa, okay, Q LoRa, long LoRa. Okay, there are a lot of resources are available. So we'll see one by one. See, LoRa and Q LoRa. Okay, so this is like parameter efficient fine tuning. So when you are talking about the fine tuning, so there's one method, parameter efficient fine tuning, which include the LoRa and Q LoRa. So I'm not going into the deeper on this one because this is again the out of the like syllabus for this. So you have to be low rank adoption. So you don't have to worry about it. You don't have to do the code of all these things. There are a lot of libraries are available already to do all these things. So you have to be focused on which one will work. Okay, first. Then second, data set generation. Okay, again there's a few resources that we put in how to create a high quality synthetic data for fine tuning high quality synthetic data. Again they are also saying the high quality synthetic data. Okay, so there are a lot of tools and libraries are available which will help you to do all this thing. So you can see the instruction response config. Okay, one more thing that I want to highlight here, every LLM model choose first which is the base model that you are going to be use. Okay, once you will select that base LLM model that you are going to use, in that condition what will happen, you have to be specify what the instruction format that you are going to be apply. Not every instruction is same. Okay, not every instruction for the every LLM model is same. No, it is not the case. You have to be choose perfectly which model you are using and which instruction model that you have to be used. How what I am trying to explain you. So I will llama instruction model for instruction format. Okay, I will share the screen. Llama 3 instruction format for fine tuning. Okay, see, see, instruction formats are different. Okay, see, fine tuning how to guides are available on Llama. See, I will show you instruction. So which see this one, llama to instruct Mistral. Okay, so its instruction template is different. Instruct system prompt sys. Okay, instruct user message this. Okay, so this is a case. Again, if you will see this one, see this one is different. Llama 3 instruct is this one. Okay, now see this one. There's a lot of different. Okay, so every model have different OpenAI message format. See, this is the OpenAI message format in this particular manner. Okay, so this is a way that you have to be do. Okay, again, fine tuning models. So if you will click on the fine tuning models, so there are a lot of fine tuning models already available on the together.ai website. Full fine tuning. Okay, LoRa context, long context fine tuning is available. Okay, so they already did it. So again, I'm saying that whatever the base model that you are going to be selecting, so you have to be change. You have to be select the instruction model according to that. Got it? Once you will select, then you have to be choose, and you have to be set the speed, Q LoRa, what is your particular target output that you are looking. On the basis of that, you have to be take a decision. So this is how that the things will going to be happen. Now there is a very important thing is available, which is the introduction to model quantization. What is model quantization is very important. So like anyone know like about, yeah, I think, yeah, Gensins have some doubt. Please go ahead. Ask what the question, what the doubt that you have. Please go ahead. Janshin, please ask your doubt. Happy to answer. Okay, till that he will ask. So we'll continue. Quantization. So quantization means we have the model. So model size. What is a model size? Billions of parameter. Okay, I will show you that as well. What is the size of the model? Okay. Uh, see. So here the maximum batch size, minimum precision type. Okay, all these things are available. Okay, but this is not what that we are looking, to be honest. Okay, so I will see this leaderboard will help us. What is the size of? No, again it is not. Yeah, take example from here. 70 billion, 8 billion. Okay, so again here like 7 billion. Okay, so in that case what will happen? The more billion parameter that available in your LLM model or base LLM model, and after you are fine tuning on your data, again it will increase or decrease little bit. Okay, it's totally depend how and what technique and how much the data that you are using. So what will happen? You have to, what you have to do, you have to make sure yourself that it should be run perfectly without taking the longer time. So in that case quantization will be come into the picture. When you are applying a particular technique to reduce the size of the model, so it will perform a very good manner. Okay, so this is what that's known as the quantization. So quantization in a single term method for reducing the size of a model. It involves the transforming the model weights from high precision floating point to the lower precision floating point. Example, 16 bit from 16-bit to 8-bit, 8-bit to 4-bit floating point. This is known as the quantization. I will repeat, quantization is the technique can reduce the size of the deep neural network and improve the inference latency and throughput by taking the advantage of high throughput integer instructions. So there are a lot of the methods are available on the internet where that will reduce from 32-bit to the 16-bit, 16-bit to the 8-bit. So this is a way that you can able to do it. What are the ways? So naive quantization is there, hybrid quantization is there, selective quantization is there. So there are a lot of the methods are available that you can do. But again, when you are quantization your model, you are reducing it. Okay, you are reducing it. So what will happen in that condition? There will be the there will be the possibility that accuracy also will be going to be reduced. So what you have to be do, you have to make sure, make sure that particular answer, particular accuracy of your model should not be going away or should not be going reduced. So this is the way, again you have to take a decision. That's why from a day one of the this particular program I am saying that your job is not going anywhere, because at every step you have to take a decision. At every step you have to take a decision and take a proper decision in a such a way that you will able to give the best to best result. So this is known as the quantization. Okay, anyone have any doubt? Okay, no doubts. So this is about the quantization. So we see the fine tuning. Okay, so you can go and do the fine tuning. So we'll do the basic fine tuning in next session. Okay, live. So in this session we are covering the concepts, we are covering the basic things. So we'll do the basic like fine tuning techniques, and we'll explore more in the coding part in the next session. Don't worry about it. Okay, now we'll talk about the agents. Why everyone is talking about the agent? What is the difference between the agents and the what we can say, the normal solution? Okay, so agent is all about, see, take example, whenever you are building any gen AI application. Okay, gen AI application, okay, which is like prompt, knowledge base with RAG technique, then LLM model. This is how it is. But what will happen if you will ask something which is not in the RAG, okay, or your knowledge base? What will happen? It will give some random answer which is not be suitable. So what we will do, we will create this particular thing, okay, this particular thing, and will integrate some tools, okay, outside tools, okay, like weather API, okay, news API, or like search API, whatever it is. So if the particular answer is not available, then they will the system will use this particular API, go into the data, go into the like particular API, fetch the data and give you. This is the one thing. And also it will add the reflection. What is the reflection? Reflection means whatever the result that particular model or the system is giving, they will think about it. Okay, is it good or not? So when it is going to be happen, it is known as the agents. That's it. There is a no difference is available. I will repeat, whenever you are creating the any LLM gen AI application, you have the prompt, you have the like knowledge base, okay, with the RAG and LLM model. Got it? So I will create a something like this. Okay, after that, if you will integrate some tools outside weather API plus news API plus search API, any API or multiple tools also you can be integrate. And after that also you will integrate the reflection. Here memory is always be there. In the RAG also you can integrate the memory. That's not a big issue. Okay, so I will add the memory as well. Okay, if these two extra things will be integrated in this particular pipeline, this is known as the agents, and this is I will say RAG Gen AI project, and this is agentic RAG or agents. agents or agentic rank. That's the only single difference is available. Nothing else is there. Nothing else. So don't be worried about agent is something superficial thing which can be do everything. No, this is not a case. You have to only integrate the some outside tools giving the data. Example, you have been giving the old data which is available, but your company website is updating each week, but you don't have the time to update your knowledge base. So what will happen? You can give your company's website whatever the question is not available, then you will give the proper prompt and the logic in your particular project, and you will say if this question is not available in the knowledge base, go on the google's go on this particular website which is our company's website, and what you can do, you will able to go and try it out and see the result is available or not, and think about that particular result is best or it is good or not. That's it, nothing else. This is known as the agents. Got it? Hope now you will able to understand the major difference between it. Got it? If anyone have any doubt till now, please go ahead. Again, happy to answer. Okay, so no doubts. Now we'll see there the key term is very popular nowadays, multi-level agents. So what is a multi-level agents? When you have the, again, multiple agents are available. Okay, multiple agents. So you have the master agent, okay, that is take caring of the other slave agents. Okay, and example, I am your manager and I am managing the different people to accomplish a particular project. So I know the whole requirement. I am giving the particular requirement to the particular my particular like team member. This will this is you will do this work, you will do this work, you will do, and once they will complete, they will submit to me. I will review it, give the feedback. If it's okay, then I will okay it and just put it into the my whatever where that I have to put. If not, then I will give the feedback, then they will work again. So this is a way that we are doing in the real world, the same way the master and slave or multi-level agents that I can say. multi Sorry, my bad. Multi-level agent architecture. Got it? So this is known as the multi-level agent architecture. That's it. There's a nothing. So you have the multiple like agents are available, master slave is available. So a particular master particular master agent will take care of the particular all these things kind of things are available. So I will give you the this thing, so that will give you the much more. mm, See, agent tools are available. See, agent is tool, calendar. Hey Google, stop. Yeah. So agents, tools are available. This one, take the action, planning, reflection, self-criticize, change of thought, sub-goal, decomposition. There are a lot of things that come into the planning, reflection, think how the things are working, self-criticize. If it will not criticize what the job has been done by the particular model, so it is okay or not. Chain of thoughts mean we know prompt engineering. Sub goal decomposition, the proper goal has been given and we are dividing into and assigning into the proper particular model, that is known as the sub goal decomposition. Long term memory, short term memory, that's we know very well. Okay, so this is the agent part. Okay, that's it. If you will see, this is a multi agent simulation. So this is one person who will take care of this person will take care of this. So whatever that we are doing in the real world, the same thing that we are trying to mimic in the in the our like GenAI world. This is LLM agent, this is LLM agent handling the different kind of the agents, trying to accomplish the work with that. So this is known as the multi-level agents. Got it? Anyone have any doubt till now? Okay, no doubt. So I will summarize pointers that we studied. Fine tuning versus prompt engineering. After we see what is the need of the fine tuning, what is the need of the prompt, and all the projects related it. Okay, when to apply what particular direction. Okay, quantization we see, multi-level agents and architecture that we see. So this is all about for today. So we are going to cover the coding and other part in the next two sessions, next session. Okay, and see how well that we can implement all these things using the different libraries are available in the market. Got it? So that's it for now. So everything is available on the website. You can go and check it out the website. Okay. So this is the website. You can go and check it out. And there's academy section is there. You can also join our WhatsApp community. So you will get to know all the updates about the program. And this is a week 5 that we are currently on it. Okay then, thank you so much to be with me for the long 30 minute of the session. Bye, take care, good night. We'll meet in the next session.